Hey guys, welcome back to my channel. Hope you guys are doing absolutely great. So the problem statement that we have today is count all subsequence with character C, right? So earlier we have solved a problem which deals with how we can print all the subsequence with character C. Now we are saying that we just want to count the subsequence with character C. So again, this is a variation of original problem that we solved earlier in our earlier video, which basically states how we can print all the subsequence. If I pull up that sheet, so this was the problem statement. This is the original problem statement. All the problem that we have solved post this video is just a variation of this problem statement, right? So it is very important for you to have a good hold on this problem statement, which is how we can print all the subsequences. If you understand this, it will be lot what I can say is convenient for you to solve all the variations with respect to the subsequence problem we have, right? So we have a problem statement here saying count all subsequence with the character C. Now suppose we have provided with the input string ABC, right? So what would be the output? For string ABC, all the possible subsequences are A, AB, ABC, AC, B, BC, C and empty string, right? So the output we expect for our problem statement here is 4. How 4? How many subsequences are there? How many subsequences are there which consist of C? So we have this one, this one, this. We have 4 subsequences, right, which has the character C in it. That's why the output is 4. We have manually done that because the input is small, so we were able to do it that manually. Now if I this is the pseudo code that we have written for print all subsequences. Now we need to do some modification to this pseudocode itself so that we can solve or we can get a solution for this problem statement that we have today, right? So what are the changes that needs to be done in this pseudocode? So first is look at the base case, right? If you see, it says if I greater than equal to n, and then I am straight away printing out the data structure and I am saying return. This needs to be updated. Now what it will become is like this. I will say if I greater than equal to n, right? If my index is reaching to the last element, last position, I could say, what I need to do is I need to check if my data structure, that is temp, contains character C or not. If it does, I will return 1, or else I will return 0. So this is the new base case that I need to write, right? So what does this mean? So whenever, if I look at the recursion tree here, right, whenever I am hitting the base case, this one base case, if my data structure consists of a character C, I will return 1, right? If it doesn't consist of character C, I will return 0. Straightforward. If my if my data structure consists of character C, I will return 1, and if my data structure doesn't consist of character C, I will return 0. This is what we are saying here. Right? Understood? Fine. Now what is another change that we need to make? We need to make change in this recursive call. Now the recursive call would be, we will have a variable called left is equal to, and uh, whatever this function will return me, I will save in this variable left. I plus 1 temp. I will come to that why we are taking variable left. I will explain you shortly. Again, for this recursion call, I need to do some updates. I will say int right. I will store it in my variable right. Right. So I am saying basically I am basically saving the output from my recursive call, because my function is now returning 1 or 0, correct? My function is returning 1 or 0. This is the base case, right? This is the base case. Whenever I call the recursive function, my base case will be hit at one point of time, and it will return 1 or 0, right? So whenever I am calling a recursion function, I expect that it will return 1 or 0, correct? So I have left and I have right. I have stored my recursive call value output into these two variables, right? Now at the end, I will add a statement which is return left plus right. Now what does this mean? What is left, what is right? So let me show you the recursion tree again. So suppose we are hitting base case here, and we are saying that yes, we have in my data structure I have C characters, so I will return 1. But in this scenario, if you observe, we don't have C in my data structure, so I will return 0. So what I'm saying is, for every recursion call we have left portion as well as right portion, right? Left portion basically says the whether to include this element in my result set or not, and the right portion says whether to exclude right portion basically states that what if we exclude the element from the my data set, right? So we need the count of left subtree, also the right subtree, right? I want all the ones from the left subtree, all the ones from the right subtree. That's why we are saying left plus right. We are first of all we are identifying how many ones we are returning from the left subtree here, and we are identifying how many right ones we are returning from right subtree here, right? And at the end we are returning left plus right. I hope this makes sense to you. Maybe you can uh, uh, write a recursion tree yourself. You will understand it in a more better terms, right? So I think this makes sense to you. I will proceed with the demo Java code. I will update you with that shortly. Okay guys, so this is the demo Java program for our problem statement count all subsequence with character C. So let me go through this code. Very easy to understand. We have a variable data called ABC, and I have a function and I have a main block, right? So in function it takes again two parameters, index and data structure. For because we are working on Java, I have a list data structure. I am calling it as temp, right? And in the base case, so this is my base case, right? So in the base case I am saying whenever my index reaches the end of my data string, I need to check whether my data structure contains C or not. If I have C in my data structure, I will basically return 1, or else I will return 0, right? That's about base case. And now we have our actual logic. I am adding the element at index I in my data structure. Post that I am calling a recursive function with index plus 1, and I'm passing on the data structure, and whatever output it gives me, I am storing it in the left variable. I am doing a backtracking here. and then I'm again calling a recursion function, but this time I am saving the output of this recursion function in my variable right, and at the end I am just returning left plus right. So this should give me the count of all subsequence with character C, right? It is a very straightforward program to understand, right? Let me just run this. So as expected, there are four subsequences which contains character C. So I hope you understand this problem. And again, I repeat, if you want to understand any problem based on subsequence, you have to have a good understanding, or you have to have a good hold on the very fundamental program called print all subsequences. I have that video for printing all subsequences in my playlist, so please go through that video once again, right? Okay, then see you in next video. Thank you guys.